For this problem, we need to find the Fourier series coefficients for the periodic waveform, which is a half-wave rectified sine wave, where we have this v of t for when 0 is less than or equal to t, and then t is less than or equal to t divided by 2, but make no mistakes that these are different t's. The lowercase t for time, and the uppercase t is for period. We're also given Vm is equal to 12 volts, and that's going to come into handy when we write out our equations. So, looking at the notes linked below the like button, we're going to get this, and this is going to help us solve for our AV, AK, and B of k. We also have a note about our omega there as well. So, looking at this, let's start out with the first one, A subscript V. So, A subscript V is going to look like this. We're going to set it equal to 1 divided by t, and then we're going to have the integral, right? This is super basic. And now we need to find the lower and upper bounds of our pi, or our period, sorry, since the uppercase t, or the t naught, is our period. So the period is from here to here. That's our period. But we have a half-wave rectified sine wave from 0 to 2 pi over 2. So we're not looking at all of this, but we're looking at this specific part here. So knowing that, we're going to go from 0 to t divided by 2. Now, we need to plug in our f of t. Our f of t, right here, is going to be this v of t right here. It's going to be a little hard to see, so I'll just underline it here. And so plugging this in, we are going to have sine, and then in parentheses we're going to have 2 times pi times t divided by t, and then of course we have our dt because it is an integral. And so this is going to be our equation. Now again, if we look at the notes linked below the like button, or if we just Google it, we know that the integration of sine is this. So it's going to be -1 over a cosine at. And we can assign our a in this problem to be all of this. So this is going to be a, and this is going to be our t. So we can rewrite this. We're going to have a 1 over t out front, and then we could put some brackets here to separate it. We're going to have a -1 over our a. But since our a is in the denominator and we have a fraction here, we can just flip it. It's going to be a minus t divided by 2 pi. That's just a little simplifying trick. And then we're going to have cosine, and then inside of here we have our a, so it's going to be 2 pi over t the right way, and then we have the t, so we have t in here, and then we can close this off, and then we need our t divided by 2, and then our 0 right here. So this is going to be our current equation, and now we can start plugging things in. We know that we were solving for t, so what we're plugging in for is in terms of t. We're still going to have our 1 over t out front. I did make a mistake though. I just realized that we have this Vm with our sign right here. So we should actually have a Vm right here. And so we can, since this is a constant, we know what it is. It's 12. We can factor it out and it'll be Vm out here. So we're going to have a Vm over t. Remember, the Vm is 12 that was given to us. And then inside of here is where we have the negative t over 2 pi, but in fact this is also a constant, right? Because it's not the lowercase t, so we can factor this out as well. So we can have times negative t divided by 2 pi. The more you factor out, the less you have to deal with later. And so we are going to have cosine inside of here 2 pi times the t, and inside of here we're going to have t divided by the 2 times t, and then we can close this off, and then we have minus the next part, and the next part is cosine 2 pi times 0 divided by t. And so this is going to be our equation. Now, looking at the far right one, it's going to be in here. It's going to be zeroed out. All of this inside of here is going to become 0. So cosine of 0 is just 1. We're going to have a -1 inside of here. And now we can look at this other one. We see the t's are going to factor out. The 2's are going to factor out. We have cosine of pi. Cosine of pi is just -1. So we have a minus 2 inside of here. We can rewrite this out. I'm going to come over here. We're going to have our Vmax. Oh, actually, let's do this out here as well. We can cancel out this t with this t. Let's plug in our Vmax. Our Vmax is 12 volts. And this is going to be divided by our 2 pi. And then we can continue with our brackets because inside of here we have a negative 2. So we can cancel out the 2's, and then we are just going to have a negative 12, which is incorrect because I forgot there's a negative out here as well. I never carry that over, so we should have a negative out front here. So we have a negative 12 volts divided by 2 pi times a negative 2. So the 2's are going to cancel out. The negatives are going to make a positive, and then we're just going to have 12 volts divided by pi. And 12 volts divided by pi is approximately 3.82 volts. So the answer for this first one is going to be 3.82 volts. Now we need to find A subscript k. Fortunately, we have this equation right here that was given to us, which is pretty good. So we can start by writing it out. Our A subscript k is going to look like this. We have the 2 over t always in front, right? This is given to us in the equation. And then we have our period, what we're going to. This is going from 0 to t divided by 2. And then we have our f of t. Our f of t is the Vmax times the sine of 2 pi times t divided by t. So this is our equation, right? And then we also have the cosine at the end. So we have cosine. I have k written in here, but it really should be, or I have n written here, but it should be subscript k. We changed it here and here, so we should stay consistent and change these both. So we're going to have, and they mean the same thing. They're just variables. They're placeholders, so it doesn't really mean anything. Then we have k omega t, or omega naught times t. Well, omega naught, we know we can find by setting it equal to 2 pi over f, or times f. And we know f is frequency. Frequency is equal to 1 over pi. So we can substitute this f with t. So we have more of the same variables here. And then we, of course, have this dt at the end right here. And from here, we can actually plug this into a calculator. And I didn't plug it all the way into the calculator, right? Because it can't solve for this because we have this k that we're going to have to look at later. So we're going to get this. I plugged in the integral, and I'll just scoot this over so we can see what I plugged in. The integral sine of xt cosine of yt. Now the x I'm substituting for all of this. This is our xt, and then the y is all of this I'm substituting in for. So let's bring it back up so we can clearly see it. And it's going to give us this equation right here. And so this equation is going to look like this. Don't worry about the constant, because the constant c at the end is because I didn't have any upper or lower bounds. Here we do have upper and lower bounds. I just didn't factor it in. I just wanted the actual equation for it. So now we can solve for this. Let's rewrite this. We just took the integral of it with the calculator. We have our 2 times t out front. Our Vmax is a constant, so we can throw that out front as well. Per our integral, we have a 1/2 out here as well. And now we can start writing inside of here. Okay. So we have a negative, we have a fraction. It's going to be cosine of our first, the x, xt. So we are going to have 2 pi times t divided by t, plus our y, which is k times omega, or 2 pi times k divided by t times the lowercase t. So this is our numerator. And now we need our denominator. And so our denominator is just going to be x plus y. And it's going to be basically what we had up top minus the t, the lowercase t. So we're going to have it look like this. And so this is going to be our equation. That should be a k. And remember, we have to minus the next thing, right? Or actually, no, this is good. We won't plug anything in yet. Remember, when we do this, we have to have our limits over here out like this. And so this is going to be the equation that we are looking at. Before we start plugging things in, we can do some simplification, right? So I'm going to take out these 2's, and we're just going to be left with a Vm over t out here. And then in here, the denominator, this is only for the denominator, we can factor out a 2 pi over t, and we're going to have a 1 plus k. And we can factor, well, technically we can't factor this because it's fraction, but what we can do is we can multiply the top and bottom by t over 2 pi. And what that does is it cancels this out with this, and then we have this t 2 pi up top. It is a constant, so we can factor it out at the front. This t and this t will cancel out. And so we can rewrite this. We're going to be left with a v max, right? We still have that divided by our 2 pi. And so that is going to be the constant out front. Later, this is going to turn into a 6 over pi when we plug in our v max. But let's just focus on what we're doing now. So let's plug in our t over 2, start plugging in our values. So we're going to have a negative out here. It's going to be the cosine. And when we actually plug this in, we can see that we have a 2 pi over t right here times a t over 2, again, once we plug this in. So the 2 over t and the t over 2 are going to cancel out. It's going to look something like this, 2 pi over t times t over 2. So you can see these cancel out, these cancel out. And so we're just going to be left with pi. And so in here, we are going to just have a pi, and then we'll have a plus, because this is the same thing, except here we have a k. And I just realized I made a pretty big mistake. And my mistake was I only looked at this part. I forgot that we totally have this part out here. That doesn't change our equation a lot though. So we can still keep all of this that we've done over here, the simplifications and everything. There are just some things that we have to add in. Not really change, but just add in. So we're going to move this over. And then in here we can see that we have a minus out front. But it's really just like this, except this and these signs are replaced with negatives. So I'm just going to copy all of this. And in fact, this is going to be the same too. So what I'm going to do, like I said, is I'm going to copy all of this without the bracket. And then I'm going to paste it right here. And so I'm going to come in, I'm going to modify it just a little bit. So that is going to become a negative. That will also become a negative. And so down here, we'll have a negative. That was a pretty good erase. So negative and negative here. And so in accordance with our integration, this is what we are going to have. This is what we're working with. It's pretty big. So let's continue on with the line we were on. This is still okay. We're still only dealing with this part right now. This is the only thing we're dealing with. We've already dealt with the out front, right, with this, and now we are dealing with this part first. And so we're going to have a 1 plus k here, right? And then we have to have a minus. We're going to have a cosine, and we can see this is basically the same thing. We're just going to have a pi minus k. And then inside of here, we're going to have a 1 minus k. And then we have to plug in the 0. So we're going to have to do minus this next part. If our lowercase t is 0, it's going to cause this to 0 out and this to 0 out. So we're going to have the negative cosine of 0 divided by 1 plus k. And we can see that the negative cosine of 0, well, cosine of 0 is just 1. So we're going to have a negative 1 here. And then we're going to have basically the same exact thing for this next one. We're going to have a minus. And because when we take this, we're plugging it into here. And then we're going to plug it into here. It's kind of how it works. It's just basic integration. We're going to have cosine of 0 again, because all of this is going to be 0. So we're going to have a minus 1 over 1 minus k. And so we can manipulate this a little bit further. And I should close off this bracket. We're going to manipulate this slightly further. And in manipulating this, we can, let's see, we're going to multiply, kind of cross multiply like this. If we add everything together, the k's are going to cancel out. And then the 1's are going to be added together. So up top, we're going to get a minus 2, and this is divided by. Now we have to multiply the denominators together. So in doing this, we are just going to get a 1 minus k squared. So this is our equation here. I did realize I made another mistake when doing all this math in my head. When we look at this, and we plug in our t over 2, I don't know why I skipped over the pi. It should be 2 pi over t, right? Times our lowercase t. And we're going to plug in t over 2 for here. T's cancel out, the 2's cancel out, and we have a pi, right? Which I included right here. And it's the same thing for this one. All we have is a k. So it's going to be pi times k. So inside of here, right here, we should have a plus pi times k. And then inside of here, we should have a minus pi times k. So this is what we are going to have, right? Now, we need to find a way to simplify this. We really do. What we can do first is, like we did on the right side, we can combine the denominators together. And so we can even write this on one line. And this is negative because there's 2 negatives here, but there's a negative out front. So this is just going to become a positive, right? And so in combining these, we'll have our Vm over 2 pi out front. And then inside of here, we are just going to say, well, we have a negative cosine pi plus pi times k times the 1 minus k. Remember, like cross multiplying. Then we have a minus cosine, and then we have a pi minus pi k, and then we have a 1 plus k. And then this is all going to be divided by 1 minus k all squared. Okay, so what we can really do is just put this all in the same denominator, and we can just have a plus 2 out here. So this is going to be the equation that we're working with, right? Now, we are going to have to heavily simplify this because it is not very simple right now. And so to simplify this, we're going to start with inside of here, this pi plus pi k. Whenever we add pi to something, we're basically adding a negative to it. Because when we look in a circle, right, if we have, say, this value right here, right, this value, let's say it's just going to be, we'll say 0. So it'll be right here, right? Well, if we add 180 to it, it's going to be over here. And so it's going to be a negative, right? Because the cosine of 0 is 1. Cosine of pi, which is 180, is negative 1. And so knowing this, we could just take this pi out here, or in here, and put it out here as a negative. So that'll get rid of this pi inside of here. And we could do the same thing with this one right here. We have this pi inside of here. Take it out, and that's going to be a negative right here. It's going to make them a positive. And then this negative right here, it's not important because it just tells direction. So if looking at this one, and I'll circle in a different color, right? This one, we have pi times k, right? Well, okay, let's say that k is 2. We have a minus 2 pi. Well, minus 2 pi is going to go like this, right? And it's going to hit here. When it hits here, it's going to be a 0, or I'm sorry, it's going to be a 1 comma 0, right? Well, that's if we have the minus 2 pi. Let's say if we have 2 pi, right? If we have 2 pi, well, we start here at 0 always, and we're just going to go this way. And where do we end up? The same place. So that's why we can make this into a plus. So let's rewrite this because we have a lot of colors in here right now. In rewriting this, we are still going to have our Vmax out front, which I'm going to plug in 12 for. We were given 12 for our Vmax. I'm going to plug this in as 12. We're going to have 12 over 2 pi. So dividing this out, we're going to get 6 divided by pi. Inside of here, the negatives cancel out, or they combine together to make a positive. That's more like it. We have cosine of pi k, and then we still have this 1 minus k, and then we have plus cosine. Remember, we changed this to a pi k, and then we have a 1 plus k, plus 2, all divided by a small 1 minus k squared. So this is our equation now. And we know that if we factor these together, a simple trick is to not worry about the cosine pi k, because you could really factor it out. You could say it's like cosine pi k, and then inside of here you have 1 minus k plus 1 plus k in their respective parentheses. So you can basically add these together. In adding these together, you're just going to get a 2, right? Because the k's are going to cancel out. Ones are going to add together, and so we get a 2. And so we are going to basically just have a 6 over pi, and then inside of here we have a cosine. Well, since this is 2, we are going to have a 2 cosine pi k, and then this will be divided by our 1 minus k squared. And so this is basically our equation. If we were to simplify it, all we would do is just add these two together. Not add them, multiply them, but combine them. This is it. This is what we have. We're going to stop right here. But how do we get the answer? So let's look back here, right? It says find a of k. It gives us the denominator. That's nice, right? We can see that our denominator is correct. And it's saying volts, right? It's in volts. It's measured in volts because our V of m out front is in volts. And it's saying for all evens. Well, what does that mean? It means that when we plug in our k right here, k must be even. So let's try to plug in an even number for it, right? Let's say we have a 6 over pi, and then inside of here we have a 2 cosine. Plug in any even number you want. We can plug in, like, I don't know, we can plug in, let's just say 10. We have 10 pi divided by 1 minus k squared. Now, if we have 10 pi, it's basically just going around a circle 5 times because a circle is 2 pi. And we know that if we go around a circle, or not a circle, if we go around the 180 twice, because 2 pi is 180 times 2, right? So 2 pi is a whole circle. Going around the circle 5 times is just always going to give us 0. So this cosine right here is, well, what's in here is 0, right? Because we're just going to go around the circle once, and that's 2 pi. Again, that's 4 pi. Again, 6 pi. Again, 8 pi. Again, 10 pi. So as long as we have an even number, we're going to get a 0, which it's asking for. Okay. And then cosine of 0 is equal to 1, and that's it. The sine of 0 is 0. So we're going to have all of this be 1, and we're going to be left with a 6 times 2. That's 12 divided by pi, 1 minus k squared. We can see that we don't have a pi in our answer, so we're going to actually have to divide this out. In dividing the 12 divided by pi, because that's all we have to do. We already have the other thing. We are going to, actually it's not there, but we are going to get 7.6 as our answer. So we're going to have 7.6 divided by 1 minus k squared volts for all even. And this right here is all the work that we've done for it, as well as some of my mistakes. Sorry. This is all the work that we've done for it. This part right here. So all of that is B. All of this up here was A. Now let's look at C. It's going to be a lot smaller. So C will do over here. We need to find BK. And we're given BK in the equations. We have 2 over t. And then we have the integral. We know what we're looking at is from 0 to t. And we know our equation, f of t, is v max. This is a constant, so I'm going to throw it out front. We're going to have sine times 2 pi times lowercase t divided by uppercase t. And then we have sine inside of here. We are going to have a k times our omega naught times t, and then we're going to have dt. Well, remember, omega naught we found earlier up here, omega naught, we found that to be 2 pi times t. So we're going to have 2 pi times t. And we can see that other than the k, these are both practically the same. That's going to come in handy in just a second, okay? But let's look at this first one right here, b of k. And I'm going to solve for it in blue, just so we keep things nice. So b of k is for k even and for k odd greater than 1. So we can plug in any value as long as it's greater than 1. So plugging in anything greater than 1, let's say we plug in 2. We plug in 2 for k. So in here, we're going to have 2 times 12, which is 24, divided by t. We're going to integrate from 0 to t. We're going to have sine 2 pi, and then we're going to have t divided by t, and then we're going to multiply this by sine. Our k, we said, was 2 for this example. We'll just use k of 2. We're going to have 4 pi times t over t dt. Now, whatever value of t that we plug in here, we're always going to have an even number times pi. And remember what I said right here? We're always going to either be right here or right here. In which case, either case, sine is 0. And we're just going to have a 0 times a 0. And so that means that this is equal to 0. Because this will be 0, and this will be 0. And so the answer for this part is 0. And now let's look at the next one. So we're looking at b1 now. So all we got to do is substitute our k for 1. So we're going to say k is equal to 1 here, right? We're going to have our 24 over t out front. We're integrating from 0 to t. We have the sine. We have 2 pi times t divided by t. And then we have sine. And remember, we're looking at this one, the one that's not been manipulated yet. And then in this k, we have a 1, right? So we're going to have 2 pi over t times t dt. Well, these are the same. So we can say that all of this is equal to sine squared of 2 pi over t times t. Well, now what do? We can't take the integral of this, right? We can't take the integral of sine squared to something. So I've circled what I want to be x here. I've plugged this into Symbol Lab with taking the integral with respects to t, and we're going to get this as our equation. So we're going to use this to solve for it. If we wanted to do this by hand, all we would need to do is use trigonometric identities and manipulation. Basically, you'd have like cosine 2 of x be equal to cosine squared x minus sine squared x. Now, these are different off the top of your, like just looking at it, but you can substitute the cosine squared x using the trigonometric with cosine squared of x plus sine squared of x equals to 1, manipulate it, and you'd still get the same thing. But since we already have this done by us for our calculator, we are just going to start plugging in our values. We have this 24 over t out front, and then inside of here we have the 1/2 times our t, and then we have minus 1 over 4 times x. Now, since this is in the denominator, we can flip it up. Our x is 2 pi over t, so we are going to flip this. We're going to have t times 2 pi, and then we are going to have the sine of 2xt. We don't need the c because we have limits. Remember, the x here is going to be our 2 pi t, and then we have this little t. And so then we have to have our limits, which should be t over 2. I don't know why I have it just as t. It should be t over 2 for all of these. We're going to have t divided by 2, and then we have this 0 here. So now we can start plugging in our values. We have our 24 over t out front. Inside of here, we're going to have 1/2 times our t over 2, and that's going to give us a t over 4. We have a minus. Inside of here, we have a t divided by 8 pi, and then we have sine times. Plugging in our t over 2 into here, we can see that the t's are going to cancel out, the big t's, and then one of the 2's are going to cancel out, so we're going to be left with just a 2 pi. because a lot of the stuff just cancels out. So that's good. And that's it for that part. Now we have to take care of the 0. So we have a minus the next part. We're going to have a 0 because plugging 0 into here, 0 times 1/2 is 0. If we plug in a 0 for all of this, it's going to give us a 0. And sine of 0 is equal to 0. Well, cosine of 0 is equal to 1, like right here. And so we are going to just also have a minus 0 in here. That's super simple. We don't need to worry about that. If we take this sine 2 pi, right? Sine of 2 pi is just equal to 0 because it's going around the circle. And we just come back to 0. So all of this is going to 0 out, and we're just going to get 24 over t times t over 4. The t's are going to cancel out. 4's are going to divide by 24, and we're going to get a 6 as our answer. So for our b of k, we're going to have a 6 here. And that is the answer and work for this entire problem.